A lot of learners struggle to understand reactions in aqueous solutions, which I've abbreviated as AQ solutions here on the screen. Before we get to what happens when we add substances to water, we need to go and look at how these substances came to be. If we look at NaCl, for example, which is basically table salt, we have an example here of an ionic compound, which means the interatomic force here is ionic. In more detail, if you look at NaCl closely, the bond that formed here actually exists between ions, and that's why it's called an ionic bond. Na plus and Cl minus have opposite charges, and due to these opposite charges, they are attracted to each other. This force of attraction is also known as an electrostatic force. And when we have NaCl, we're actually looking at Na plus and Cl minus. If we go and look at another substance like, for example, HCl. HCl is hydrochloric acid. This is an example of a covalently bonded molecule. So when we go and look at the interatomic force a little bit closer, we know that hydrogen has 1 electron and chlorine has 7 electrons in its outermost orbital. Therefore, there is an electron pair that they will share, and this sharing of electrons is known as covalent bonding. So when we add NaCl to water, it will have a different effect than when we add HCl to water. Let's go and just look at this closely. NaCl is actually already in ion form, which means that when we add this to water, we are going to get the ions to dissolve. So we see that this is going to lead to the formation of Na plus, and now we add Aq and Cl minus Aq. The Aq basically means that the Na plus is surrounded by water molecules. If you can imagine Na as a positive ion there, water has a positive and a negative side. The oxygen side of water is slightly negative and the hydrogen side slightly positive. So the negative side of water is going to surround the Na plus, and therefore we will see that we have Na plus in solution in the water, and therefore we add our subscript now as Aq. Because the water doesn't actually react with the NaCl, we add water above the arrow to show that the NaCl didn't have a chemical reaction with water, it just dissociated or dissolved. So this is an example of a dissociation reaction. Dissociation reactions will occur when we have ionic compounds. If we go and look at what happens with HCl, HCl has to form ions because HCl doesn't have any ions. HCl is a covalent molecule, therefore there was no ion formation. So when we have HCl in water, it has to react with the water. We then see the formation of H3O+, which will be Aq, and Cl-, which will also be Aq. This is an example of an ionization reaction. The reason why this is called an ionization reaction is because the covalently bonded chlorine and hydrogen have to become ions. What happens to the hydrogen is it will attach itself to the H2O, and this leads to the formation of the H3O+, and then we see that the Cl will become an ion Cl-. So when we go and have a look at what HCl looks like in water, it will be H3O+ aqua and Cl- aqua. Now, as you can see, both NaCl and HCl led to Cl- being in the water. But with NaCl, the Cl- wasn't formed, it was already Cl-, while HCl, that chlorine had to become chloride. So when chlorine becomes an ion, it is called chloride. Now, how do we know that H3O+ formed and Cl-? What we know here is when we look at HCl, Cl already has 7 electrons in its outermost orbital. Therefore, Cl loves to become Cl minus or chloride. Therefore, we know that Cl minus will be one of our products, and therefore the hydrogen that is left will attach itself to the water. Make sure you know the differences between ionic compounds and covalent molecules. Also, water itself will never be aqueous, because aqueous means that something is dissolved in water. If you take water and you add more water, you just have water. So the phase here for H2O is L, or liquid, all throughout the content.